Welcome in everybody to another lesson. Today we are going to talk about the volume of pyramids and cones. So here we have a square pyramid, meaning the base of the pyramid is square. You go by whatever shape the base is, that's what type of pyramid you have. Now in a prism, you would have two bases that are the same shape. In a pyramid, you only have one base with the shape. Just going up to some point up high, at one focal point up high. That's what a pyramid is. So, of course, if we had a square prism, that would technically be a cube. But we have a pyramid because there's only one base. To find the volume of a pyramid, it is 1/3 of the area of the base times the height. Well, why is it 1/3? The idea is that if you put a square pyramid inside of a cube, it'll fill it up 1/3 of the way full. That's why, therefore, the volume is 1/3 times the area of the base times the height. So, we're going to derive the formula here for the volume of a square pyramid. Of course, you still have your 1/3, but what is the area of the base, which is a square? What's the area of a square? It's just one of your sides squared. 1/3 times one of your sides squared, then you just multiply that times the height, and you'll have the volume of your pyramid, your square pyramid. So, let's say one of the sides of your base is we'll say it's 5 feet, right? 5 feet. Now the height of this pyramid, it can't be any of the slants on the side going upward. The height has to be straight from the ground to the high focal point that's encloses the top of the pyramid. In this case, we're going to say the height is 10 feet. Okay, so to find the volume of this pyramid, we're going to take 1/3 times one of the sides squared, which would be 5 feet, that being squared, times the height, which we deem to be 10 feet. Okay. Now, of course, the order of operations dictates that we do the exponent first, so you'll still have 1/3. But that 5 to the second power, that's 25. And then feet to the second power, well, that's feet squared times the height of 10 feet. Okay, so let's see how much room I have here so y'all could see. I think y'all could see pretty well here. Now we just have a straightforward multiplication problem. So we're going to do the 1/3, do that times 25, then do that times 10. You get approximately 83.33 feet squared times feet, that's feet cubed. So the volume of this particular pyramid here is 83.33 cubic feet. Alright, that wasn't too bad. Let's do another square pyramid. Let's do another square pyramid here. Now, of course, people often know the greatest examples of pyramids are those in Egypt. Well, it was long thought that the pyramids in Egypt, the bases were perfect squares. Up until recently, that was thought to be true. But archaeologists have actually determined that two sides of the pyramid are actually 14.4 centimeters longer than the other two sides, which technically makes it a rectangular pyramid. But we'll go into rectangular pyramids in a second. So let's say we have 17 meters for the one side of the square. We'll say the height. We'll say the height's about 40 meters. All right. So of course we want to take the volume. We want to have the volume here of this particular pyramid is 1/3 times the side of the square squared, so which would be 17 meters. That would be to the second power times the height, which is in fact 40 meters. Okay. Now, of course, the order of operations would dictate that we do the exponents first. So you would still have 1/3. I think 17 squared is 289. I want to be sure. It is. 17 to the second power is 289. Meters to the second power is just that. Meters to the second power. Times the height, which would be 40 meters. Now we just have a simple multiplication problem, and you'll find the volume of your square pyramid. So we'll have 1/3, all that times 289 times 40, which is going to be approximately equal to 3,853.33 meters squared times meters. That's cubic meters. So the volume of this pyramid is 3,853.33 cubic meters. That's for a square pyramid. Now we will do a rectangular pyramid just for good measure. So let's erase this part. The overall volume is still the same. It's 1/3 of the area of the base times the height. But we are going to set up a rectangular pyramid. You can have a pyramid with any base. It could be a triangle, it can be a pentagon, it can be, you name it. But I'm just going to show you the most common types, being rectangular and rectangular as well as square. Alright, let's go ahead, draw the top of this here. Draw the focal points. As I said, I'm not the best at drawing, so I do apologize, but we'll get there. Alright. Let me just erase that excess at the top. Alright, so we have a rectangular pyramid now. So, of course, in order to find the volume of a rectangular pyramid, you still have 1/3, but what is the area of the base of a rectangle? The area of a rectangle, that's just the length times the width. You have the length times the width, and then you multiply that all by the height and get the volume. So the volume of a rectangular pyramid is 1/3 times the length times the width times the height. Well, in this case, let's see. The rectangle could be 23 feet. That would be for the length. The width of it would be, I don't know why, like 17 feet. We'll do that. Now when they refer to the height, that's from the very top of the pyramid coming down to the ground of it. So the height, let's say that's 31 feet. We'll make the height 31 feet. To find the volume of this particular pyramid, you're going to take 1/3 times your length, which would be 23 feet, times your width, which would be 17 feet. The first two measurements we've just put in are for the base, being the rectangular part of the pyramid. Then you have the height, which we determine to be 31 feet. So all you have now is just a straightforward multiplication problem. This one doesn't involve any exponents, so you can go straight through and do your multiplication. Come on, calculator. 1/3 times 23 times 17 times 31. That comes to about, I should say approximately equal to 4,040.33. Then you have feet times feet times feet. That's cubic feet, or feet to the third power. So the volume of this rectangular pyramid is 4,040.33 cubic feet. And that's really all there is to finding a rectangular pyramid. We'll do one more example with a rectangular pyramid. Then we're going to move on to cones. We'll move on to cones here in a second. Alright. I'm OCD a little bit. I gotta erase everything perfectly. Okay. Let's say the length of this square, this rectangular base of the pyramid, let's say the length is 50 meters. We'll make it 50 meters. The width we can say is 40 meters. The height, we'll call the height 60 meters. That'll be the height of this rectangular pyramid. So to find the volume, once again, you'll take 1/3 times the length of the base, which is 50 meters, times the width of the base, which is 40 meters, and that's the area part of the rectangular base of the pyramid. Now we just need to multiply that times the height, which would be 60 meters. And you're left with a very straightforward multiplication problem. So let's go ahead and do this again here. We got 1 divided by 3. That's all times 50 times 40 times 60. At which point you get 40,000. You would have 40,000 meters times meters times meters. Well, that's meters to the third power, cubic meters. So the volume of this rectangular pyramid is 40,000 cubic meters. So with pyramids, and this is going to be true with cones too, but with pyramids or cones, we'll talk about pyramids for a minute, the volume is 1/3 times the area of the base times the height. And it's 1/3 because a pyramid or a cone fills, a pyramid fills 1/3 of a prism, where a cone fills 1/3 of a cylinder. So we are next actually about to talk about cones. Okay, where did I put it? There we go. Let's talk about cones. Or just, we'll say a cone. So, of course, you have your circular base. You have your circular base, and then you have, of course, you have your height, meaning at one focal point on the, at one focal point above the circle. That's a cone. A cone basically, it just has one base, kind of like a pyramid does. You could think of it almost like a circular pyramid. That's what a cone is. It only has one base, which is a circle. That's a cone. If it had two bases, it would be a cylinder. But and only has one base, it's a cone. So it goes from the base up to some point up high where it closes off the 3D shape. So, of course, you have your radius of that circle. You have the radius r of that circle, right? To get the volume, you're going to take 1/3, of course. But what is the area of the base being a circle? The area of a circle is pi r squared. Now you take 1/3 times the area, you multiply it by the height, so you have your official volume formula for a cone being 1/3 pi r squared times h, or 1/3 times pi times the radius squared times the height. I'm trying to show you where these formulas come from. If you know the area of the base of the shape, then you can get your volume, because you're just simply going to multiply that by the height. You'll have your volume. I find it a lot more effective to do it that way than just simply giving you the formula saying this is the formula. Good luck remembering it. No, I want to show you where it comes from so it's easier to remember and easier to understand. But let's say here, right, we have, let's do the radius of 3 inches. We have a radius of 3 inches. The height, it can't be the slanted sides again. It's going to have to be coming straight down to the center of the circle. It comes straight down from the top to the center of the circle to make it the height. The height, we will say, is about, let's call that 15 inches for the height. The height will be 15 inches. So to find the volume of this cone, you're going to have, of course, 1/3 times pi times what is the radius squared, which will be 3 inches. That'll go to the second power, times the height, which we determined to be 15 inches. Of course, order of operations dictates we do the exponents first, so you'd still have 1/3 times pi. Now 3 to the second power, that's 9. Inches squared is just that, inches squared, times your 15 inches. Alright, now at this point we just have a simple multiplication problem. So let's see, 1/3 times pi times 9 times 15 comes to 141.37. So the volume of this cone is 141.37 inches squared times inches is inches cubed. 141.37 cubic inches will be the volume of this cone. Of course, classic examples of cones can be funnels, which not quite, because they're a little bit more circular at the one bottom part, so it's not quite a true cone. You could have those cone paper drinking cups. Those are fairly common. Ice cream cones aren't. I mean, you could have waffle cones that are cones, of course, but your average ice cream cone you think of isn't truly a cone. So, but I'm just giving you some examples of cones, what to look for if you want to find a cone out in the wild. Alright, I'm going to do one more example here of a cone. Let's say we'll have 15 millimeters for the radius, 15 millimeters for the radius, and 50 millimeters for the height. We'll say it's just one of those big cone cups, one of those big cone paper cups. I don't think those are the exact dimensions of one, but I'm just kind of making it up. What I think it would be, but I don't know for sure. But let's say this paper cup has a radius of, this paper cone cup has a radius of 15 millimeters. The height of it's 50 millimeters. The volume for that cone is going to be equal, of course, to 1/3 times pi times your radius squared, which would be 15 millimeters, that quantity squared, times your height, which would be, in fact, 50 millimeters. Alright, of course, again, order of operations dictates we do the exponent first. So you'll have 1/3 times pi. Now, what is 15 squared? That's 225. Millimeters squared, that is just that, millimeters squared, times your height of 50 millimeters. Okay, now that we've done our exponents, we just have a straightforward multiplication problem. So let's see what we get here when we plug all this in. One-third times pi times 225 times 50 would give you 11,780.97. 11,780.97. So you have 11,780.97 millimeters squared times millimeters is millimeters cubed. So the volume of this cone is 11,780.97 cubic millimeters. But yeah, that's really, whether you're dealing with a pyramid or a cone, the general idea for the volume is roughly the same. Whether you're dealing with a pyramid or a cone, the volume is always equal to 1/3 of the area of the base of the pyramid or the cone times the height of the pyramid or the cone. And again, the reason it's 1/3 is because a pyramid fills 1/3 of a prism, a cone fills 1/3 of a cylinder. That's why that's where the 1/3 comes from. If we were talking about the volume of a square pyramid, of course, you have 1/3. That doesn't go anywhere. The area of the base being a square, the area of a square, well, that's just the side squared. Then you take all that times the height. That would be the area of a square pyramid would be 1/3 times the side squared times the height. Now, if you have a rectangular pyramid, of course, you're going to have 1/3 not going anywhere, but the area of the base, the rectangular base, is length times width. That's the area of a rectangle. To take all that times the height, the volume for a rectangular pyramid is 1/3 times the length times the width times the height. And finally, in closing, when we talk about cones, of course, 1/3 goes nowhere, but the area of the base being a circle, the area of a circle is pi r squared. And then you just take all that times the height. You have your volume formula for a cone being 1/3 pi r squared times h. That's all you would have. Again, my goal was to show you where these formulas come from, so you're much more likely to succeed at remembering these formulas and understanding them if you know where they come from, as opposed to just giving you a formula saying, here you go, good luck, remember it. I don't believe in doing that. I like to show you where it comes from. So next lesson, we're going to be done with volume. We're going to talk about angles and different types of angles. So I hope everybody has a good day. Take care.